Today, we're gonna show you that over Unity using this kind of setup is not possible. We're gonna set up 4 different tests using the highest quality neodymium magnets available. You may have seen a similar popular video using these kind of curved magnets. We're gonna mount them on a 55 amps cut alternator rotor. We're gonna use a 120 volt motor to spin the alternator. We're using a motor that can turn about 1500 RPM, which is about a half of what a typical alternator would need for a normal output. In theory, we could multiply our test result by 2 to get the ballpark number, and this would give us about 20 volts output. And here's a good reason why we're using a hot glue gun versus the permanent resin mixture. We can remove the magnets from the hot glue using just a carpenter's knife and a screwdriver. That way we can do multiple experiments using the same rotor. And we can use a heat gun to clean the rotor. For the second test, we're gonna double the magnets. And this time we got about 12.3 volts. We'll multiply it by 2 to get the ballpark number of about 25 volts. We're using a blowtorch to prepare the rotor for the third test. This time we're using longer and thicker magnets. They should give us stronger magnetic field. And this time we got a little better results, but we're still far away from 120 volts. So we can upgrade both the car alternator and the electrical motor. This is a 200 amps car alternator, and the previous one we used was a 55 amps alternator. This is a 1 horsepower motor versus a 1/3 horsepower motor that we used in the last 3 experiments. But this time we're gonna utilize all 3 power phases. And we're gonna manually control the alternator magnetic field. We're using a 3 amp 13.8 volt power source and a 30 ohm rheostat. The rheostat controls the current of the rotor, which in turn controls the magnetic field strength. That way we can control the voltage output from the alternator. We're gonna utilize all 3 output phases. Since we do not have access to a transformer that can convert 3 phases to 2, we're using a 300 amp DC full bridge rectifier. So you'll see DC voltage instead of AC voltage. Let's listen to the full sounds of the system. The 1 horsepower motor had stalled before the maximum design magnetic field of the alternator was applied. But what does that mean? It means that a 1 horsepower motor cannot handle the load of the 200 amps car alternator. The stronger the magnetic field in the alternator, the more load that the electrical motor has to pull. The safety mechanism in the motor shut down the motor to prevent damage from overheating or too much current draw, which makes a system like this not possible. The motor will simply just shut down when the alternator tries to produce more energy, which means stronger magnetic field. But how did we get this to work? The answer is, we did not. We manipulated the motor. And here's how we manipulate it over Unity. We removed the rotor and we took out the 20+ pound stator core. And we shoved all these inside the motor. Some of the viewers from my last video guessed spot on. Good job, guys. On top of that, we had 2 identical motors. This motor has the original wiring. And this is the modified motor. The first thing you notice is the shaft is hollow. That is because the fan is controlled by this small motor. And here is one of the 2 battery packs. This is a 300-watt inverter. And here is part of the second battery pack. This is the remote control switch. And here is one of the 2 relays. And here is the complete second battery pack. This is the second relay. And the belt is driven by this DC motor. Well, if you made it this far, you are a mighty legend. Don't forget to smash that like button and thank you for watching.